All right, so you will have a quiz over this information without your calculator. Just want you to be able to do this and really know it without letting the calculator do the work for you. A polynomial. So a polynomial in one variable, a polynomial function is a polynomial with one variable and real coefficients. Real being, 2/3 or 1/2 or 8. Okay, not irrational like I. Right? So the degree. How do you determine the degree of your polynomial? Well, we've kind of discussed this, and you talked about it last year. How do you determine the degree of your polynomial? It's the highest exponent, right? So your degree is determined by the highest. So your degree is determined by the highest exponent. What is your lead coefficient then? Anybody know? Right. It's the number right in front or connected to that term. Okay. So your degree is the highest exponent. And it doesn't have to be found in the first term. I mean, if I wanted to make you look, I could jumble this all up so that your degrees are not in descending format, right? So you have to look for it. Okay? So it's the highest exponent. Lead coefficient is the number in front of the term with the highest exponent. Okay, and this is always is a problem for you, the terminology for this, all right? A zero versus a root. They basically are the same thing. They're just two different ways of expressing that same value. If I talk about a zero, I'm talking about where the graph crosses the x-axis. In other words, it's known as the, what's another word for that? Which intercept? It's the x-intercept. If it crosses the x-axis, it's the x-intercept. And if it's the x-intercept, then what equals 0? Yes. So if it's the x-intercept, that means y has a value of 0. So when I ask you for the zeros, I'm asking you where does the graph cross the x-axis, at what value of x, okay? But likewise, if I give you a polynomial and I say, tell me what the root is, well, basically, it's just saying solve the polynomial. Let y equal 0 and find the solutions. So again, if I'm letting y equal 0, then obviously we're finding values for what variable? X. So aren't we again finding the x-intercepts? Right? So if we're setting y equal to 0 and we're solving for values of x, then we are finding, again, the x-intercept. So that's what I'm saying. If I ask you for a 0 or I ask you for a root, those are interchangeable terms. They mean the same thing. Okay? Allie, your computer? Okay. All right, fundamental theorem of algebra. It's really kind of a cool little theorem. I mean, it is, because what this chapter is going to be about is finding all of these roots. Okay, but the fundamental theorem of algebra says whatever the highest exponent is, that's how many solutions I'm going to have. That's how many places my graph is going to intersect and cross the x-axis. So if my highest degree is 5, I will have 5 solutions. That doesn't mean that I have 5 distinct solutions. Distinct meaning different. Okay? Maybe 0 occurs 3 times. But it means I have no more than a possibility of 5 places or 5 values or solutions. So the fundamental theorem is the highest exponent determines the possible number of zeros or roots. So I'm going to use these terms I'm going to interchangeably so that you get used to hearing that, okay? Now, the reason I say possible, these roots are complex. Now, what does complex mean? Complex means either real or imaginary. So I'm going to be dealing with I. Oh, yes. Oh, wow. Okay. So, can we graph imaginary roots or solutions or zeros on our coordinate graph? No, we can only graph real values, right? But that doesn't mean that there aren't other solutions out there. So maybe if my highest exponent is 5, if 2 of them are imaginary, because they're always coming in conjugates, right? One's going to be plus and one's going to be minus, because you're dealing with the quadratic formula, thank you. The other 3 would be real values that you can actually plot on your graph. Okay, so that's why I mean you have a possibility of 5 roots. Some might be imaginary and some might be real. All right, so let's look. Here's an example. State the degree and the lead coefficient of the polynomial. So what is the degree? And it's determined by this value right here. So the degree is 4. Lead coefficient, what is the lead coefficient? Okay, always tell me if it's positive or negative, because sometimes if it's negative, then you want to tell me it's -3, okay? But in this case, this 3 determines that my lead coefficient is 3. Okay, is -2 a 0 of the polynomial? Well, how am I going to determine if -2 is a solution? If it's a 0? If it's an x-intercept? Plug it in, and what should you get? Y should equal 0. So we're going to substitute. X equals -2 and see if y equals 0. If we don't get 0, then we know, well, no, that's not a 0. It's not a root. It's not a solution. Okay? So f of 2 is equal to 3, 2 to the 4th plus 2 minus 2 to the 3rd plus 2 squared minus 1. Oh, Lord have mercy. Thank you. All right. So this is going to give me 3 times 2 to the 4th is positive 16, yes? And then this is going to be minus 2. And this is going to be -8, but then really it's going to be positive 8, yeah. No calculators because I want you getting these signs right. Okay? And then plus 4 and then minus 1. So this is 48. This is 6, 10, and 9. So what do we say? If we get 57, is it a root? No. Because we didn't get 0. It's only going to be a root if our final answer is 0. Because a root means where it crosses the x-axis. It means it's a value where y is 0. No, we're finding if -2 is a 0. Yes. We're going to talk about synthetic division again. Yeah. Allie, why don't you turn the fan down a little bit? I think, are y'all warmer in here now? It'll put Lindsay to sleep. I don't know when you don't fall asleep in my class. Here we go, moving on. All right, what does I represent? Square root of -1. What's I squared? -1. What's I cubed? Never 0. These either were forms of i's or ones. Yeah, it's a negative I. It's the square root of -1, square root of -1, square root of -1, right? But these two are -1, and this one is I. Therefore, it's negative I. Do you remember this? Yeah. Yeah, you do. I to the fourth. I to the fourth is 1. And then the pattern begins all over again. Your value or your simplification should never have anything higher than an I to the first power. Because anything higher than I to the first power can be simplified down into another value. All right, here we go. Given roots of 3i and -3i. I will tell you that if you have i's in there, they will always come as a pair. And remember I said they will always be conjugates. One will be positive and one will be negative. Because you've used the quadratic formula to get that value. You've done 3 plus and minus, and then there comes your I because it was under the square root. Okay, so these always come in conjugates. You'll see something like this on ACTs and SATs. Well, they'll give you 3, and they'll ask you what's the other root. Or they'll say 3i. And then you'll need to see that the other root is going to be -3i because they come together as a pair. If I gave you 2 plus I, what would the conjugate be? 2 minus I, because the conjugate changes a sign, one sign, in between the two terms. Okay? All right. Write the polynomial equation for this. Well, remember, if I'm giving you roots, these are your x values. Wouldn't you agree? That meant x is equal to 3i, x is equal to -3i, and x is equal to, that's how we got our roots. Now, we got our roots because we had them in factored form, right? Correct? So these are the solutions. Now, in factored form, that meant we would take this and move this back over to the left, correct? So x equals 3 becomes x minus 3i in factored form, yes? And x equals -3i means in factored form, what was it? And if x is equal to 2, what is your factored form? So remember, I'm looking for the equation, right? Yeah, the equation. That means I want the polynomial. I want the polynomial. So we're going to distribute. Now, here's the thing. Which two parentheses do you want to work with first? Yeah, it's because they're going to cancel out. Okay? They're conjugates, and those middle terms will drop out. So you're going to get x squared plus 3ix minus 3ix minus 9i squared, which drops out the middle terms and leaves you with x squared what? No. Plus 9. So remember how we said that this was not the difference of perfect squares, that we can't factor this, right? X squared plus 9. You always wanted to try and factor that out further. It is a different, it's a perfect square, but you've got i's in there. X plus 3i, x minus 3i gives you the plus with the x's and the 9 being divided out. Okay? What is I squared? So isn't that minus 9 times -1 gives you plus 9 as that last term? Does that make sense? Okay. Okay, so now we continue by letting this be multiplied by x minus 2. So we get x cubed minus 2x squared plus 9x minus 18. All I did was FOIL. And this is what my y is equal to. This is the equation. Y is equal to that value. Okay? Now, we're going to sketch it. Body graph this. Where are the tails? It's going up. Okay? I'm running out of room. We'll do it over here. Can anybody tell me what the x-intercepts are? The only real solution is at 2, right? Because 3i and negative 3i are the other roots, but those are not something that you can graph. So we know it crosses here. We can also determine the y-intercept. What's the y-intercept? Negative 18. Here's negative 18. Don't we know what this should probably look like now? If we did a little sketch, we know it's going to come down and go up. Something like that. So we're getting more and more information on how to graph these polynomials. This is good enough. All right, let's look at the next one. And we know that it's only going to cross the x-axis once, right? We could have said that it's going to loop around and eventually the tails are going to go up, right? But the only place where it crosses is at 2. So that's the only time it can cross or touch or hit the x-axis. That's why we know it doesn't loop around, okay? All right, so here we go. X is equal to negative 2. And again, x is equal to negative 2. And x is equal to 4i, and x is equal to negative 4i. What should be the degree of this polynomial? It should be 4, because how many solutions do I have? 4. Okay? 2 of them repeat. 2 of them repeat, but I still got four solutions. Okay? Now, you need to be careful and notice that these repeat. Notice that they repeat. All right. So that means I have x plus 2, and x plus 2, and x minus 4i, and x plus 4i. That's my factored form that gave me those roots, yes? Okay. These are conjugates, right? So the middle term drops out, yes? So if you can jump to this without doing all the work, do it. This is x squared minus 16i squared. You should start seeing these patterns. You need to see these patterns for next year with calculus about how to do these, okay? Which is really x squared plus 16. Agreed? Okay. This is a pattern too. This is that times itself. Can you do it in your head? Well, we're going to have x squared. What's my middle term finally going to be? Plus 4x. And my last term? There we go. Save yourself some steps. Okay? You need to start seeing this pattern. Okay, now this, I mean, I can't do this in my head and write it all out, so I need to show it. So I'm going to get x to the 4th plus 16x squared plus 4x cubed plus 64x, right? Is that right? Plus 4x squared plus 64. So simplifying our like terms, I have an x to the 4th. I only have one term with x cubed. I have 20x squared. I have 64x, and 64 equals my f of x. How are we doing? All I did was combine my like terms. Abby? So, in our mind, we knew the highest degree should be what? And that's what we got. Okay? All right. We know that the only place where it's going to cross the x-axis is at what value? So we know it's doing something right here. And we know that the y-intercept is where? Way the heck up here. We know from the last chapter, what is the shape? Where are your tails? Where are your tails? If it's even and positive, it's up. So what am I going to do to get my tails to do the right thing, to hit it only at this value? It reflects, right? So we're doing something, coming up, doing something. So when, and so again, this is why it is so important that you know where are your tails if you're going to be drawing this, because I will expect you to be able to draw this. If you're going to tell me it's this, well then I don't know what you're going to get, not what it's supposed to look like. Okay? Molly? Because this is my y-intercept. When x is 0, this drops out, this drops out, this drops out, this drops out, I'm left with 64. Okay? So remember I said pay specific attention to the fact that -2 repeats. If it repeats an even number of times, it bounces. Your graph bounces at that value or gets reflected. If it is an odd number of times, it passes through that root. Very important that you know that. So if your root occurs an even number of times, the graph bounces. Touches it and goes back up in that same direction. It doesn't pass through it. Pass through it means it would have gone through and had it ended up in a different quadrant. Right. I mean, because if we would have passed it through, well, then guess what would have happened? If we wanted the tails to both be up, wouldn't it have to cross the x-axis in another spot? Right? But we knew that there were no other x values or x-intercepts, so we have to create a bounce. All right, so root occurs even number of times, the graph bounces. If it occurs an odd number of times, then it passes through the x-intercept. Okay? Yeah, for right now, I just want you to know something's going on in there, but it's only going to touch it here, and it's going to go through the y-intercept of 64 with tails both going up. Okay? Okay. Here we go. What's the degree? What's the lead coefficient? +9. Find the complex roots. How am I going to find the complex roots? Now, factor. Okay, can I use the quadratic formula? No. Why can't I use the quadratic formula? No. What is the quadratic formula for? What should the highest exponent be for a quadratic? Squared. What is the highest degree here? 4. Can't use the quadratic formula because the degree is too high. So we look at factoring. All right? Yeah, in some format. Okay, and that's why I kept giving you factoring problems earlier this year, because you can't forget how to factor. Here's a reason. All right? So how do I factor 9x to the 4th minus 35x squared minus 4? Well, if you want to use the box method, fine. You just are going to put a 9x squared and a -4. Thank you. That's what I meant. Yes. Okay. All right. So we need the product has to be -28 and the sum -35. Sorry. Holy moly. It's Monday. Thank you. -36. So what would my factors of -36 be? That gives me -35. And 1x squared, right? Yep. I changed my 2 to a 4. All right, so what do I pull out here? A -4. What do I pull out here? x squared. What do I put out this way? 9 and 36. 9x squared, wouldn't you agree? Because x to the fourth and x squared can pull out an x squared. And the factors of 9 and 36, 9 is common in both of those factors. You can't forget how to factor. You didn't do the box method? Okay, well, whatever. Then you factor however you want, all right? And then here I'm going to pull out just a 1, because there's nothing that can get pulled out. And so my factors are 9x squared plus 1 and x squared minus 4. Now remember, I'm looking for my root, so I'm going to set this equal to 0, correct? I can do one of two things. I can factor it further, or I can just say, well, that means 9x squared plus 1 equals 0. So 9x squared equals negative 1. So x squared is equal to negative 1/9. And x is equal to what? Plus and minus square root of well, if you've got a negative sign under the radical, it automatically turns into what? I. What's the square root of 1? What's the square root of 9? So isn't this 1/3 I? Right? Are we good? Okay. Here I'm going to say x squared minus 4 equals 0. So x squared is equal to 4. So what does x equal? Yes, don't forget your plus and minus because it will just mess with your answer. How many roots am I supposed to get? What's the degree? How many are real? Which ones are real? Okay, what's my y-intercept? -4, +2, -2. Where are my tails? Up or down? Both up? One up? Heads up? 7 up? Both up. All right. So we know that it's doing something like this. Why are there no bounces? Because all of them don't repeat, right? I mean, and if it's just an odd number. If each of them occur only one time, correct? 1 is an odd number of repeats. No bouncing. Well, so these are my x roots. It's passing through, right? It's the x's that we're talking about. The y-intercept is going to always pass through. We're talking about our x's. Yes?
So since you can't graph 3i, that just kind of goes away?
It's an extraneous root. It is a solution, but not something that we can graph. Okay? How are we doing? Some of you are falling asleep. All right, y'all do this one. Can you simplify? What do you mean by simplify? Maybe. Also, how many terms are there? 4. You remember how to solve or grouping, right? This is a grouping problem. I'm just going to put this here. How is that? How can, when you take the square root of 1/2, you still get 1/2? Sure, but my denominator was a perfect square.